Welcome back guys. Let's continue from the previous lecture of mesomeric effect. First part la enna paathom appadina what is mesomeric effect and how is it used for acidity and basicity. In this lecture we are going to be seeing mesomeric effect in terms of electrophilic aromatic substitution. Either part 1 or part 2 la kandipa question varum every year, maybe from both of them, so you want to be very strong in that. As always we will do some examples as well. Okay. Alright, what is electrophilic aromatic substitution? Okay. Throughout the lecture and also throughout the year I will be using this as the abbreviation EAS. So electrophilic aromatic substitution basically means substitution now ஒரு இடத்துல இருந்து யாரையாவது எடுத்துட்டு அதே மாதிரி இன்னொருத்தரை போடுறது. இங்கே electrophilic-ன்றனால I am going to be taking an electrophile, replacing it with another electrophile. Okay. Now here is a pretty good example. I have taken only benzene ring here. In a benzene ring, you can take a hydrogen. So there are 6 hydrogens. You can take any hydrogen. So I am basically going to look at this hydrogen. I am going to remove it. Eppadi remove panna electrophile ponuna. Electrophile is something that is electron loving. So hydrogen ponom appadina hydrogen ku badala na vera oru electrophile podrena adu electron loving ah irukkona adula electron irukkodadu. So H plus is the electrophile I am taking out. E plus is the electrophile I am replacing it with. Okay. So H plus ku badala E plus poda porom. It is seen as 2 different steps. Step 1 is slow step. Slow step is extremely important to know. This determines the rate. Kinetics part we will look at it again later after kinetics lecture. At this point just know this is the slow step. Slow step la enna agum appadina in the pi cloud will attack the E plus. So attack of the E plus electrophile by the pi electron cloud of the benzene ring. It attacks and form a CE bond. See, you can form the CE bond. And the pi electron வந்து ரெண்டு கார்பன் நடுவுல இருக்கு. This carbon is using the pi electron, meaning this carbon is losing the second bond. So it gets a positive charge. And that positive charge is stabilized by resonance. And you get the corresponding substitution reaction. Second step is loss of proton. You want to remember this name. It's called a sigma complex. The sigma complex is the intermediate transition state. You will see more about transition state in thermodynamics. It's also called an areninum ion. Now this is the simple, very simple setup for a benzene ring. Now what about if it's more than a benzene ring? How about substituted benzene ring? So substituted benzene ring என்னும் போது அந்த பென்சீனில் ஏதோ ஒன்று இருக்குது substitution. So let's say Y is a substitution. Okay. So if this is present, how is it going to affect? Where is the electrophile going to go? There are possible positions: ortho polam, meta polam, para polam. For a mono substituted product, poly substituted ortholiyum polam, metaliyum polam. We are going to see who is going to determine that. If suppose எல்லா பொசிஷனும் ஒரே மாதிரி இருந்ததுன்னா, if they are equally reactive, then there will be equal amounts of ortho and meta substitutions. Correct? எல்லாமே ஒரே மாதிரி இருந்தால் எல்லா இடத்துலையுமே அட்டாக் ஆகும். ஆனால் ரெண்டு ஆர்த்தோ இருக்கனால 40% ஆர்த்தோ கிடைக்கணும், ரெண்டு மெட்டானால 40% மெட்டா, ஒரு பேரானால 20% ஈச் பிளேஸ்க்கு போடுங்க. அப்போ ரெண்டு ஆர்த்தோனா 40, ரெண்டு மெட்டானா 20 + 20 40, ஒரு பேரானா 20. So this is what you should expect if everything is equally reactive. But that is not the case. The rate determining step is the first step, formation of sigma complex nu paathutom nama. So before this step is happening, who is attacking the electrophile? The pi cloud. And the pi cloud எந்த பொசிஷனில் ஸ்ட்ராங்காக இருக்கோ அந்த பொசிஷன் தான் போய் அட்டாக் பண்ண போகுது, where the electrophile is bonding to the ring. So the major and minor product will depend on which position has the highest electron density. Now this will depend on, this position will depend on who is present here. Ortho addition intermediate, para addition intermediate போட்டிருக்கோம். சப்போஸ் இது ஆர்த்தோவில் அட்டாச் ஆனால் என்ன ஆகும், பேரல் அட்டாச் ஆனால் என்ன ஆகும், மெட்டால் அட்டாச் ஆனால் என்ன ஆகும். What you want to look here is very carefully. If you look, if it gets attached to the ortho or para position, the carbocation C plus is right here. Okay. Whereas metal மட்டும் C plus is right here. So now it will come down to ஆர்த்தோ அண்ட் பேரா எப்போ ஸ்டேபிளாக இருக்கும் அப்படின்னா, இந்த கார்போகைட்டன் ஸ்டேபிளாக இருந்ததுன்னா, இங்கே இருந்தால் ஸ்டேபிளாக இருந்தால் ஆர்த்தோ அண்ட் பேரா ஐசோமர் வரும். இங்கே இருந்து ஸ்டெபிலிட்டி கிடைக்கல அப்படின்னா மெட்டா ஐசோமர் வரும். Carbocation will rather be here. Who will stabilize the carbocation here? Who will stabilize the carbocation here? This is what we are going to see right now. Now, if you see here, you can see electron releasing group or electron donating group. They can donate electrons, okay, into the ring. அப்படி donate பண்ண முடியும்னா அவங்களால carbocation stabilize பண்ணலாம். Correct? Similarly, electron withdrawing group அப்படினா electron withdraw பண்ண போகுது. அப்ப இங்க carbocation இருந்ததுனா ஸ்டேபிளா இருக்காது. So electron withdrawing group இருந்தது அப்படினா உங்களுக்கு ortho and para positionல electron deficiency வந்துரும், delta plus. வரப்போறது electrophile. It wants to go to a place where there is a lot of electrons, correct? So electron releasing group இருந்தா it will go to ortho or para. Electron withdrawing group இருந்ததுனா it will go to meta. Okay, it goes to meta not because electron withdrawing group gives electron to meta. That's not the reason. Electron withdrawing group வந்து ortho ல இருந்து para ல இருந்து எடுத்துறதுனால எலக்ட்ரானை வேற வழி இல்லாம மெட்டாக்கு போகும். Okay, so you want to remember this. We will see examples based on this. Before we go in, you want to remember the common electrophiles we are going to see. Before we go in detail, you want to remember all of them. These are NEET based, and the name of the reaction would be electrophile வந்து Cl2 னு வரும். and actual electrophile is E+. So it is going to be Cl+, Br+, NO2+, SO3H+. This is the electrophiles. You want to remember them, and these come from these compounds. Okay, these are the source of electrophile. If these are the source, Cl2 is the source, and எடுத்தோனே Cl கொடுத்துறாது, Cl+. Somebody has to help in achieving it. That's the role of Lewis acid. Purpose of a Lewis acid, you want to remember to generate the E+. It's a catalyst. E+ generate பண்ணும், then it will actually get regenerated. So look at Cl here. இது non-polar bond. ரெண்டுமே ஒரே மாதிரி ஆட்டம்ன்றதால இந்த bond வந்து non-polar. But இது Lewis acidன்றதால இதுல எலக்ட்ரான் கம்மியா இருக்கு. So it is pulling the electron. If it pulls the electron, there is a partial delta minus delta plus here. இந்த electron வந்து symmetrical இருக்க பதிலா இப்படி மாறிடும், more towards this. So delta plus. So I have generated a electrophile. Similarly, you want to remember this particular one. Why do you need H2SO4? The Lewis acid property is actually because of the H+ in H2SO4. That H+ will attack the nitric acid and protonate it. This is nothing but nitric acid, HNO3. It will protonate it. Protonate panna, this is what I get. This is protonated nitric acid. Oxygen male positive charge unstable, so it will try to get out of that positive charge by taking the electron and running away. Now I have a positive charge in the nitrogen atom. So this is called a nitronium ion. இதுவே question வரும், what is the electrophile in nitration சொல்லி 4 ஆப்ஷன் கொடுப்பாங்க, N மேல minus, O மேல plus, O மேல minus அதெல்லாம். Okay, you want to remember the nitronium ion. It's also written as NO2+ right here. Similarly, the same mechanism you can write SO3 இதே மாதிரி எழுதுனீங்கன்னா இதே மாதிரி H2SO4 போட்டா you get SO3H+. Similarly, the last two is actually Friedel-Crafts alkylation, Friedel-Crafts acylation. There you always use AlCl3. AlCl3 purpose enna electrophile generate பண்றது. Because this is Lewis acid, it takes the electron from halogen. The halogen takes it from here. I get R+. R+ is the electrophile in Friedel-Crafts alkylation. RCO+ is the electrophile in Friedel-Crafts acylation. Okay, now that we have seen about electrophile, where do they go? Now if you see, if it is an activating group, we already saw let me put it here. Inga carbocation வரப்போது, correct? Carbocation வரப்போது, இங்க electron density அதிகமா இருக்க போது, or இங்க electron density அதிகமா இருக்க போது. So hence you get ortho and para isomer. In a deactivating group, இங்க carbocation வந்ததுனா unstable, இப்பதான் பார்த்தோம். So the electrophile will actually go to the meta position, carbocation will come here. More precisely actually, this side and a double bond, doesn't matter. Okay, where does it go? Why does it go that way? Okay, now you can see here, it's a very good illustration. This is a electron with donating group. This can donate electrons. So electrophile inge pona inge varapora carbocation stabilized. So electrophile goes to ortho and paras as major product, and meta does form that, but that is a minor product. Now which of them are electron donating group? Last lecture le paathom, the ones that are plus M or plus R group. They are also called ortho-para directors because they direct the incoming electrophile to the ortho and para position. This is all last lecture la nama paathadam. Similarly, when you take the meta product, it is formed by electron withdrawing group. The blue is the electron withdrawing group. If it withdraws electron, ortho and para is unstable, so they become minor, meta becomes major. And this also we saw in last lecture. Minus R minus M group along the meta director because they enrich, I should not say they enrich, they make the electron density in ortho and para deficient. Okay, ortho and para la kammiya irukanaala meta director ah podu, whereas inge vandu ortho and para edirpaathadoda adhigama irukum. Okay, but neither of the cases, you want to remember again, neither of the cases the meta position is rich in electron compared to benzene. Okay, benzene compare panna rich ah irukuma appdinu nama sollave illa inga, that is different. Let's look at an example. Okay, plus M effect or example paakalam. I have taken here anisole. Anisole is a what type of group? Plus R, R plus M rendume onnu dhaan symbol. It's a minus I group by the way. Okay, so minus I அப்படினா electron withdraw பண்ணும், but resonance is stronger நம்ம பார்த்துட்டோம். So the pi cloud here attacks the electrophile E plus and forms the corresponding carbocation here, which is stabilized by this resonance, especially stable. Same thing can happen in para. Understand neatly in the structure inga varayave portal, this is for your understanding, whereas in meta it is not formed. All you want to know is look at this for understanding the lecture. This is what you want in the NEET exam. avanga kuduthirukradhu anisole ah irundha electrophile pota, all you want to write down is the effects. Ortho la enna effect paaka poringa neenga? Plus R, correct? ena idu vandu plus R minus I group. Ortho la appo na vandu plus R minus I um paapen nanu at ortho position. Meta la if see only minus I, plus R varadu. Para la I see only plus R. So what's the best place it can go? Obviously para la dhaan. Plus R is better than plus R minus I, better than minus I. idla electron adhigama irukum, idla electron adhigama irukum, but idanaala konjam kammiyagum minus I naala. So it forms after this one and then this, and the corresponding isomer will be para greater than ortho greater than meta. Para greater than ortho greater than meta. So ஒரு compound கொடுத்தா உங்களுக்கு எந்த ஆர்டர்னு பார்க்க தெரியணும், and it will not be tough at all, it will be very easy. Let's do one more. Anisole பார்த்தோம், இப்போ phenol பார்க்க போகிறோம். Okay, phenol is exactly same. It can give electrons, so the carbocation that is going to be formed is stabilized, so you're going to get ortho and para as the major isomer. You can see here nitration. This is going to be orthonitrophenol, this is going to be paranitrophenol. Alright, so it is extremely good, but para is going to be greater than ortho. Why? Phenol is minus R, sorry, plus R minus I group. அப்போ இந்த இடத்துல என்ன எஃபெக்ட் இருக்கும்? plus R minus I. இந்த இடத்துல minus I. இந்த இடத்துல plus R. Plus R is greater than plus R minus I, which is greater than minus I. So para greater than ortho greater than meta. Alright, so an important thing that you want to know, two things about when it comes to phenol. Okay, one is given here. How about phenol versus phenolate? Now who is better in plus R, phenol or phenolate? We know that O minus is much greater than OH, so this is much better plus R. So this is going to give a better yield or better result. So when you look at phenol, it is much more plus R, so you always try to form a phenolate in all of phenol reactions. Now state board or CBS, it doesn't matter. Phenol or electrophilic reactions எல்லாத்துலயுமே நீங்க என்ன பாப்பீங்கன்னா, first step phenol with NaOH. Example, Riemann-Timmins reaction, or this is Kolbe-Schmidt reaction. We are going to see this in phenol lecture later also. இதை நீங்கள் மெமரைஸ் பண்ண வேண்டாம். திஸ் இஸ் ஜஸ்ட் ஃபார் யூ. ரீமட்டிமஸில் NaOH இருக்கும், coal-based methylene. Coal-based is a very good reaction to understand this. The NaOH abstracts this, I get phenoxide. Phenoxide is extremely rich in electron at ortho and para position. So rich compared to phenol, I don't need a strong electrophile. This is weak electrophile, CO2. Because plus charge illa, there is only momentary plus charge. Dipole mattum dhaan irukku. So it's very weak in the plus charge. So this is stronger irukanaala this goes and attacks here or here. So you can get anywhere you want. Okay, again here you are going to have, okay, ortho and para greater than meta, but is it going to be para greater than ortho greater than meta, or ortho greater than para greater than meta? Okay, now this is what you want to know. What are the effects of O minus? OH nu pathina minus, sorry, plus R minus I. O minus nu patha plus R plus I. Idu plus I nu pathom. Appo இந்த பொசிஷன்ல என்னலாம் இருக்கும் ஒரு phenoxide ionic? Let me write it here. So here I am going to have plus R plus I. So draw phenoxide ion separately in your notes and write this plus R plus I. Metal என்ன இருக்கும்? வெறும் plus I. Para வெறும் plus R. My plus R plus I is more electron rich than plus R, which is more electron rich than plus I. Because of that, you always get salicylic acid, not the para isomer. So this is the order when it comes to phenoxide. Phenol la பார்த்தா order வந்து para greater than ortho greater than meta. Phenoxide பார்த்தா ortho greater than para greater than meta. This is the reason why we are saying effects before, so that reactions from organic chemistry போகும்போது ரொம்ப ஈஸியாக இருக்கும் organic chemistry. Okay, let's just do a small comparison just to see what we saw before. Another point I told you, phenol na rendu point important. Innonu vandu phenol versus anisole. What is the effect of phenol plus R minus I? Anisole plus R minus I. Okay, minus I of anisole is smaller than minus I of phenol. Edhanalana there is CH3 giving electrons. Okay, so anisole should be stronger or more reactive to electrophilic aromatic substitution, but this is the order. You want to remember this. I cannot say it enough. It has come so many times in NEET. Phenol is more reactive than anisole, even though it has a better effect. Minus I kammiya irukku. Why? The plus R effect in anisole is less than plus R effect in phenol because of steric reason. In the CH3 group வந்து இந்த electron வந்து planeல இருந்து வெளியில போக வச்சிரும். So it cannot interact with the ring as efficiently as phenol. So because of the steric reason, phenol is better plus R than anisole's better plus R. Okay, so you want to remember that. OH is strongly activating group, OR is a less strongly activating. Less means it is strongly activating but not as good as phenol. So this is the order கொடுத்திருக்காங்க உங்களுக்கு. Diphenyl ether போது இந்த O வந்து ரெண்டு பக்கமும் எலக்ட்ரான் தரணும்ல. And also imagine this side, it looks like phenol, looks like an ether, correct? Except in the ether in the R group and phenyl, phenyl oda இன்னொரு effect என்ன, electron இழுக்கலாம், இன்னொன்று minus I. Because of that it comes after anisole. When I go here, actually we want to write it down here. What is better than phenol? Aniline, because nitrogen is a better donor. But the same aniline, when it is acetanilide, the lone pair has to be given to the CO also. It's tied up in conjugation. In the vaarthai munadiye paathom, tied up in conjugation. Because of that, it has competition. Inga kudukanuma illa inga kudukanuma. Because it is tied up in conjugation with a very strong group, minus R group, it doesn't give efficiently here, so it is less than this. So it's moderately activating. 4-bromophenol is strongly activating group, but Br is weakly deactivating group. You cannot compare actually here. Okay, these four you can compare. This is different, but at least know that it is competing. We are going to see in a while how competing it is. Let's go to toluene. Toluene, at this point, write down. Later, we are going to see hyperconjugation also. It's going to explain much better. At this point, we are going to see only the effect of toluene in terms of plus I. Okay, it is going to be mild plus R later because of hyperconjugation, but plus I mattume paakalam. Ortho attack pannanumna inge carbocation varum. Carbocation is stabilized, correct? It's stabilized. Inge carbocation stabilized. And in the carbocation inga form pandringa appadina, it's in resonance, correct? So it is stabilized. So idu rendume favorable ah irukanaala toluene nu paatha namalukku vandu para and ortho greater than meta nu varum. Okay, whereas meta it is not stabilized at all. Now this is going to be the same for all alkyl groups. Toluene mattulla all alkyl. Here I have ethyl benzene. Now here look at the order. Para greater than, ortho greater than meta. You want to remember this. Inductive effect mattume idu explain pannadu. Hyperconjugation will explain why ortho is not as good as para later. But at least you want to know that observed with toluene are general for any alkyl benzene. So anything that is alkyl benzene is nothing but benzene. அது கூட எந்த ஒரு alkyl group ஆனாலும் same. It is an ortho para directing group. Now we have seen plus R. We are going to see minus R, which is also minus I. Sorry, minus M. And minus R and minus M are same. NO2 group is a minus R group and minus I group. Minus R means it is going to be meta directing. So look at the quantity, 93% meta. Now what are the effects in each of these positions? Here I am going to have minus R, I also have minus I. Here I have minus I, here I have minus R, minus I irukadhu enna distance. So where is the electron rich in the density ring? Electrophile varudhu is going to look here and look here and decide, okay, my minus I is weakly deactivating compared to minus R, which is better still compared to minus R minus I. So this is your meta, this is para, this is ortho. So when it comes to your effects, okay, you want to remember para and ortho are less than meta. But among para and ortho, this quantity, see, hinge vandu eppadi irukku, meta ku appuram para appuram ortho. Sometimes it changes for a different reason, steric reason, hydrogen bonding. Ungalku adanal idoda exact percentage engeyume kekka maatanga. When it comes to minus M group, this is what you want to know. Okay, now this is just for you to see why the electron is not good in terms of stabilizing the carbocation. Hence you are going to have this order. Okay, you don't have to draw any of them. This is for you to just look at it and understand. This is the same with all the minus R groups. NO2 is a strong minus R, next in a C double bond O. Same. This carbocation here is destabilized by the minus R group, minus I group as well. Because of that, you always get a meta isomer. Halogens, it's a special case. Halogens la enna irukum appadina, I have a lone pair, 3 of them. It can be given, so it should be plus R minus I. But halogens are deactivating group because of the minus I effect. So இது எப்படி இருக்கும்னா, fluorine வந்து why is it deactivating? Because strong minus I. Chlorine, bromine, iodine வந்து it is minus I but not as strong as even oxygen. Then why is it deactivating? OH வந்து activating, ஆனா இது மூணு deactivating ஏன்னு கேட்டா orbital overlap. This is chlorine, let's say this is carbon, okay, this is carbon, this is chlorine, okay, this cannot overlap easily. இங்கே தான் பாசிட்டிவ் சார்ஜ் வரப்போகுது, இங்கே எலக்ட்ரான் E வந்ததுன்னா this cannot overlap easily because this is carbon has 2p orbital, chlorine has 3p, 2p 3p cannot overlap, 2p 2p can overlap. But 2p and 3p may overlap பண்ண முடியலனா bromine ல வந்து 4p, iodine ல 5p. So because of that the plus R is weaker. Okay, that it is in net effect is, even though it is going to be deactivating group, still the plus R wins marginally, so it is going to be orthopara director. Okay, they are going to be orthopara but not very happy about it. So minus I irukum plus M irukum, they oppose each other. Because of that the minus I is cancelled out by most of the plus M, remaining little plus M is going to be useful for orthopara director. Now you can see the para is much better than ortho because I effect para la irukadu, but meta la and the plus R illadanaala meta is less. Now this is what is going to happen. So he is going to donate electron, going to go and attack electrophile. Aniline is a special case, hence I put it like this. Aniline is an amino group. What do we know from aniline? It is a strong plus R minus I group. Extremely good compared to OH. So it is so good in plus R that bromination panna tribromo derivative dhaan varum namakku, because the electrons is rich in all the three positions, whereas phenol panna ore oru derivative dhaan. Phenol pannumo enna vandhathu para greater than ortho greater than meta. Inge vandu tri moonume substitute aidum. So what do I do in organic chemistry? No need to worry about these reactions now. In the compound kodutha ortho para one mattum paaka theriyum. Now what is the problem I have? This is strong plus R. அதை நான் deactivate பண்ணணும், கொஞ்சம் கம்மி பண்ணணும். அப்படின்னா என்ன பண்ணலாம்னா, இந்த எலக்ட்ரானை உள்ளே கொடுக்கறதுக்கு பதிலாக I can do acylation. This is called acylation. Okay, so you end up forming a amide group. Amide group பண்ணும்போது tied up in conjugation, correct? We saw this before. அப்போ இந்த எலக்ட்ரான் வந்து ஃபுல்லாக ரிங்கு கொடுக்க முடியல, பாதி ரைட் சைடில் கொடுத்ததுனால deactivated little bit. So now I can only give little. So this is like phenol now. So what I have, para greater than ortho greater than meta. எனக்கு para கிடைச்சதுக்கப்புறம் I can get back my aniline. We will look at this step later, how this happens when we study aniline. At least at this point you want to know aniline ரொம்ப ஸ்ட்ராங்காக இருக்கும். அதை கம்மி பண்ணணும்னா I can protect the group by acylation of the amine group. This is right here shows a very good example of how the lone pair is tied up in conjugation. This is one property you want to know about aniline. The second property you want to know, extremely important. When you do nitration or any sulfonation, அதில் ரெண்டுத்துலையுமே catalyst வந்து H+. H+ போடும்போது இது base. It will go and attack the H+ and form an anilinium ion. Anilinium ion வந்து இப்போ இருந்த lone pair கொடுத்துட்டனால இதில் lone pair இப்போ இல்லை. Lone pair இல்லாதனால this is only minus I. Okay, it is purely minus I. Minus I அப்படின்னா distance dependent, so it is para greater than meta greater than ortho. Completely different order. So when you have aniline and you do nitration or sulfonation, this is the order you are going to get. Okay, you want to remember that. This is actually in CBSE book also. You want to remember this order because anilinium ion தான் form பண்ண போகுது உங்களுக்கு. Okay, based on what we saw, I have just grouped them together. Activating now, straightforward aniline, OH, OR, and even NHCO is activating, but not as good as NH2. Okay, இது எல்லாமே pi electron உள்ள தரதுல உங்களுக்கு, அதனால இதெல்லாம் pi donor. Sigma donor na alkyl group என்ன பண்ணுது? Okay, plus I effect. இது actually minus I effect, weak pi donor, strong minus I. So sigma bond through a minus I, pi bond through a இது இங்கே தரலாம்ல உங்களுக்கு. So plus R ரெண்டும் கலந்ததுனால இதோட கம்மியாக இருக்கும். Halogens are plus R minus I but weaker, so they are right here. So these are orthopara directing. இது எல்லாமே orthopara directing. Among them halogens are deactivating. Okay, from here it is deactivating. Carbonyls are minus R minus I. These are also minus R minus I but very strong. So these are meta directing. Adaley idu romba stronger. Okay, this is just a picture of when a donating group is there, the electrons are given to the electrophile from these places. Okay, whereas if a withdrawing group, electrons are pulled in, so you cannot have, the electrophile will go to meta positions. Okay, now let's look into an example so we can understand this. Now this is given, what is this phenyl benzoate? Now where will an electrophile nitration will happen? Nitration is nothing but NO2 plus, for that matter NEE plus. Okay, அப்போ இங்கே போகும்போது நம்ம group வந்து effects எழுதலாம். This is nothing but O group. Okay, O வந்து electron தரலாம்ல, so this is going to be plus R minus I. What about the CO group? In the ring CO தான் நீங்க பார்க்கணும். அப்போ இது வந்து என்ன group? minus R minus I. So where is this going to go? Obviously இந்த ringல தான் போகுது, ஏன்னா plus R இருக்கு. So let's write the effects in each of the places. இங்க என்ன effect நீங்க feel பண்ண போறீங்க? I will feel the plus R, I'll feel the plus R, I'll feel the plus R. I'll feel the minus I here, I'll feel the minus I here. I won't feel the minus I. So which is the best place? Let's put the numbering. Okay, 1 2 3. இதுவும் ஒன்று தான், அதனால் 2 and 2 ஒன்று தான், 3 and 3 ஒன்று தான். 3 4 5 6 7 8 7 6. So which is the best place that is going to be? It is going to be 1 greater than 3. Okay, 1 greater than 3. Now இந்த சைடு போகும்போது என்னென்ன எஃபெக்ட் ஃபீல் பண்ண போகிறோம்? This is a minus R minus I group, so I'll feel the minus R minus I here, I'll feel the minus I here, I'll feel the minus R here. Correct? So எனக்கு எந்த effectsலாம் good அப்படின்னா plus R is good, then plus I is good. Let's write it this way, plus R minus I is good. Best வந்து plus R plus I, ரெண்டுமே எலக்ட்ரான் தருது, ஒன்னே ஒன்று எலக்ட்ரான் தருது, ஒன்று தருது, ஒன்று ரிவர்ஸில் வாங்கிக்குது. Then I can have plus I alone, then no effect, which is still better than minus I. Okay, which is better than minus R, which is better than minus R minus I. So electron நிறைய தராங்க, as you keep going down electron தரது கம்மியாயிட்டே வந்து electron வாங்க ஆரம்பிச்சிட்டாங்க. Okay, so now look at positions. plus R தான் நம்ம முதல்ல பார்த்தோம், plus R is taken 1, 3 is taken. Now is there any other plus R? No. Next என்ன இருக்கு? plus I. இங்கே எங்கேயுமே இல்லை, நோ இஃபெக்டும் எங்கேயுமே இல்லை, எல்லா இடத்துலையும் எஃபெக்ட் இருக்குது. இந்த பொசிஷனில் சப்ஸ்டியூட் பண்ண முடியாது நீங்கள். Okay, we don't substitute, we always substitute in ortho and meta and para. Next minus I. Okay, I have minus I here, I have minus I here. Which is a strong minus I group? C double bond is stronger. அப்போ இது தான் ரொம்ப ஸ்ட்ராங்காக இருக்கும், எலக்ட்ரான் கம்மியாக இருக்கும். இங்கே வீக் minus I. So 2 greater than 7. minus I அப்புறம் minus R 8. minus R அப்புறம் minus R minus. So draw this molecule. This molecule actually teaches everything you want to see in multiple examples. இதுதான் order. Okay, so 1ல தான் போக போகுது உங்களுக்கு 1. So this is the major product. All right. Now I would say you guys just rewind a little bit, do it yourself and watch the video again right here. Okay, now what if there is more than one substituent? இப்போ இந்த மாதிரி இருந்தால் என்ன இருக்கும் அப்படின்னா, this is, we can say this is plus I, good. This is minus R, good. ரெண்டுமே deactivating, ரெண்டுமே activating, good. I can decide where I want to go. இங்கே எங்கே போகும் அப்படின்னா ரெண்டு பொசிஷன் தான் இருக்குது, பொசிஷன் A, பொசிஷன் B. ஏன்னா இதுவும் A, இதுவும் B. ஓகே, ஸோ ரெண்டு பொசிஷன் தான் எங்கே வேணால் போகலாம். இங்கே போகும்போது ஓகே ரெண்டுமே டீஆக்டிவேட்டிங். தி ஆர்த்தோ பொசிஷன் ஆஃப் COOH இஸ் சேம் அஸ் ஆர்த்தோ ஆஃப் NO2. ஸோ திஸ் இஸ் நாட் கோயிங் டு பி தேர். இதோட ஆர்த்தோ வந்து இதுக்கு பேரா, இதோட ஆர்த்தோ வந்து இதுக்கு பேரா. ஸோ திஸ் இஸ் த பொசிஷன் இட்ஸ் கோயிங் டு கோ. Because what is the effect that you are going to see here? Let's write it down. Let's clear it out. Let's say, for example, this is blue, this is red. அப்போ என்னென்ன பொசிஷன்ஸில் என்னென்ன எஃபெக்ட் பார்க்க போகிறோன்னா, ரெட்னால என்ன பார்க்க போகிறோம், இங்கே -R -I. இது பேரா, இங்கே என்ன பார்க்க போகிறோம், -R -I. சாரி, ஆர்த்தோ. இது என்ன பேரா, -R -I. இங்கே என்ன பார்க்க போகிறோம், -I. ஓகே, நான் COH என்ன மாதிரி குரூப் அப்படின்னா, இட்ஸ் a -R -I குரூப். ஸோ என்ன பார்க்க போகிறோம், இங்கே -R -I, -R -I, இங்கே -I, இங்கே -R -I. நான் இதுலேருந்து இதில் பேரால் நான் இதை இக்னோர் பண்ணலாம். அதே மாதிரி இதோட பேரால் நான் -I வேணால் இக்னோர் பண்ணலாம். பட் when you look at it, which is the position that is the best possible? இதுதான் இருக்கிறதுல இங்கே தான் எலக்ட்ரான் அதிகமாக இருக்கும், பிகாஸ் இதெல்லாம் -R. ஸோ the electrophile will go. But questions like this is tougher, because this is -R -I, இது வந்து +I. ஸோ இதோட ஆர்த்தோவில் பார்க்கணுமா, ஆனால் இதுக்கும் ஆர்த்தோவாக வருது. ஸோ இட் இஸ் நாட் ஆப்வியஸ். We are going to see that soon. How do you decide? And this is the type of question you can expect in NEET. Let's look into how we can decide when there is competing groups. ரெண்டு வேறு மாதிரி இருக்குது. ஒன்று வந்து எலக்ட்ரான் தருது, ஒன்று எலக்ட்ரான் வாங்குதுன்னா எந்த குரூப்பில் போகிறோம் அப்படின்னா, this is the key that you want. Activating group always decides. They are stronger. கொடுக்குறவங்க வேகமாக கொடுப்பாங்க. Deactivating is going to be different. Okay, so you always want to look at the activating group. So now when I take given this molecule, see this is +R group, correct? +R -I, இது என்ன -R -I. So who wins? OCH3 is activating, wins over NO2. அப்போ OCH3 எங்கெல்லாம் direct பண்ணும்? Ortho to itself and para to itself, activated. Okay, so you're going to have a major product, ortho 1, para. Now you can ask me why you don't put in this ortho. We will see that. That's because இந்த இடத்துல ஒரு SO3H இந்த இடத்துல போடுறதுக்கு இடம் இல்லை, activated but crowded, because this is hitting, this is hitting. So I don't have a choice, I have to go in these two places. Okay, let's look into a couple of examples. Predict the mononitration possible products. Okay, mononitration, ரெண்டு group இருக்கு. What is the effect of this group? It's a +R group, okay, -I. This is a weak +R, weak -I, okay. I know still this is a orthopara directing group. This is also a orthopara directing. ரெண்டுமே orthopara directing, which is stronger among them. This is stronger, so this wins. அப்போ இதோட ஆர்த்தோவும் பேராக்கு தான் போகணும், ஆனால் பேரால் போக முடியாது, ஏன்னா இங்கே குளோரின் தான் இருக்குது, ஹைட்ரஜனில் ரீப்ளேஸ் பண்ண. ஸோ இட் will go to one of the ortho. They are exactly same. So it will go to ortho. It will, minor product will be here. This is minor, this is major. இங்கே போகும்போது this is +I, this is +R -I. So this is going to win. So இதுக்கு நீங்கள் எங்கே பார்க்க போகிறோன்னா, this position, this position and this position, ortho para. இங்கே போக முடியாது, ஏன்னா மெத்தில் இருக்குது. ஸோ இட் will go to this position, major, para, greater than this ortho. Why this para greater than this ortho? -I, இங்கே -I இருக்கும், இங்கே -I இருக்காது, because of the para greater than ortho. Metanitrochlorobenzene, chlorobenzene, metanitro. Who wins? This is weak +R, so it wins. This is -R -I. Definitely it will not go here. Steric reason, இங்கே பார்த்தோம், crowded. Now இதோட +R எங்கே ஃபில் பண்ணுவீங்க? இங்கே ஃபில் பண்ணலாம். இதோட +R இங்கே ஃபில் பண்ணலாம். இங்கே -I இருக்கும், இங்கே -I இருக்கும். So it will go to these positions. Which among them is very tough to decide? எதனாலனா இந்த NO2 ஓட -I is very very strong here. So because of that it may go here also. So equal இருக்கும் product almost. அவ்வளோ close examples கொடுக்க மாட்டாங்க நீட்டில். Okay, let's look into examples here. So what do we know here? This is +R, this is -R. நான் I போடவே வேண்டாம், +R -R முதல்ல டிசைட் பண்ணணும். This wins over this one. So இதுக்கு ஆர்த்தோ பொசிஷன் தான் ஃப்ரீயாக இருக்குது. It can go here or here. correct, இதோட para occupied. இங்கே போகும்போது இது plus R. Okay, so can it go here, here or here? This position no, because crowded. இந்த ortho occupied, இதுவும் occupied, so it is crowded. இங்கேயும் போலாம். Okay, இங்கே கேட்கலாம் இந்த சைடில் போக முடியுது, இந்த சைடில் இங்கேயே முடியலனா nobody here to hinder, so it's easier. இங்கே போகும்போது it's a very good molecule. Okay, this is இந்த ரிங்குக்கு இதை தான் நீங்கள் பார்க்கணும். You want to see this ring here. What effect? Minus R. இந்த ரிங்குக்கு இங்கே பாருங்கள், இது plus R. Plus R எங்கெல்லாம் போகலாம்? Ortho, para. But this is plus R minus I. So this is the position major, இது minor. இங்கே போக முடியாது because already occupied. Let's see. So ortho para director. So what you're going to get is, you can see in the molecule they have, oops, sorry, this is a different example. I'll try to fix this. Okay, let's go to this one. Okay, this is easy. Okay, either trace amount. Trace na romba kammi because steric effect. I can go here and I can go here. This is the same here. NO2 inge polam. Now they have given you NO2 inge because that is here. Now which will it be major? This will be major, this will be the next major or less, you can say. Last we are going to see is Friedel-Crafts alkylation. முன்னாடியே பார்த்தோம். Friedel-Crafts alkylation you are seen in school regardless. We are going to see this in detail later. இப்போ என்ன பார்க்க போறோம்னா Friedel-Crafts reactionல R plus தான் electrophile generated by AlCl3. This is how it is generated. AlCl3 is a Lewis acid. Aluminumல 3 bond தான் இருக்கு, 3 chlorine-ஓட. So 6 electrons தான் இருக்கு. Octet இல்ல, it wants electron. So it is going to attract, the chlorine is going to give its lone pair. Okay, partial bond formation, partial bond broken. Now when this species goes here, it breaks right here because this electron is being given. Okay, because this is being given, you end up forming this. So now this is a very simple one, alkylation. Alkylation later we are going to see carbocation rearrangement. நான் இப்போ சொல்றது எல்லாமே straightforward answers. So உங்களுக்கு என்ன பார்க்கணும்னா, if I give you Rx and the R group and inga enna R group idan, that R gets substituted here just like this. That's all. That's alkylation. And the electrophile is R plus. Now here I have shown you a couple of things. Benzene na very good, extremely good. அதே benzene ஓட இன்னும் நீங்க better Friedel-Crafts alkylation எப்படி பண்ணலாம் அப்படினா, plus R group இருக்கிற benzene ring is much better than benzene, which is better than minus R. Minus R இருந்தா ringல electron இல்ல, so reaction fails. So Friedel-Crafts reaction happens with benzene or substituted benzene with plus R effect. Substituted benzene with minus R effect like nitrobenzene does not undergo Friedel-Crafts reaction. It goes very very less that we can say it is failing. Friedel-Crafts reaction பார்த்தோம்னா acylation அதே தான், ஒரே different என்ன இங்க RCl க்கு பதிலா RCOCl, that's all. Now you want to see here RCl இப்படி உடைக்க போறோம். So I get R plus Cl minus. RCOCl we are going to break it like this. So I get RCO plus because I have broken the bond. Cl minus will go along with the AlCl3. This is called, the electrophile here, RCO plus is called acylium ion. Acylium ion is the electrophile in Friedel-Crafts. At the end of the lecture, the last slide, we are going to see the same effect of multiple substituents. Paakadan crowded is actually very simple. But toluene eduthinga romba simple. We are going to say weak plus R, pinadi paaka pora hyperconjugation plus I. So para is greater than, much greater than ortho, greater than meta. Very simple. But when you go to this particular example, you actually see para is the highest compared to your ortho. Okay, even though the plus I is very strong in ortho, and ortho la po mudiyala because steric strain. It cannot go here, it goes to para. hyperconjugation பார்த்ததுக்கு அப்புறம் என்ன தெரியும்னா there is no hyperconjugation here. இதில் hyperconjugation இருக்காது. இப்போ hyperconjugation பார்க்காதவங்களுக்கு do not worry, just focus on steric strain. But I'm assuming that you guys will watch it again after I finish hyperconjugation. அப்போ பார்க்கும்போது இதில் no hyperconjugation because no alpha hydrogens. So no hyperconjugation purely plus I. அப்போ plus I எங்கே இருக்கும்? Plus I is here, here and literally 0 plus I. அப்போ இங்கே வரவே கூடாது, ஆனால் பேரால தான் அதிகமாக இருக்குது. The reason because of steric effect. Okay, same here when you go. Orthoல போனோம் அப்படின்னா it is good but no place. I cannot put another group here. NO2 group இங்கே இடம் இல்லை. So it goes to right here. This position is same as this position. Molecular symmetry இருக்குல்ல இங்கே, அப்போ இதுவும் ஒரே position தான். Now this is a very good example. I am given here, literally this is not formed because no place here. Whereas when I have here, let's say this is plus R group, minus R group. அப்போ இங்கே plus R இருக்கும், இங்கே plus R இருக்கும், correct? So I can go here or here. So these two are expected, whereas this is not expected. This is because of steric reason, even though the electron is favoring இடம் இல்லை அங்கே போடுறதுக்கு. Alright, so this is the end of this lecture in terms of electrophilic aromatic substitution. The only way to get stronger is watch it once and then solve the problems that we just solved here and solve the problems I have given you, watch it again. It's an extremely important part. Now I would seriously advise you guys to look at the first half of mesomeric effect lecture 1 to understand the plus R minus R again. Okay, alright, thank you guys.